This video will show you how to use Thermo-Calc to calculate a phase diagram for the oxide system, aluminum oxide, magnesium oxide. The aluminum oxide magnesium oxide system is one of the basic systems of metallurgical slags and refractories and is important for understanding these materials. This calculation can be run by anyone with a license for Thermo-Calc and a TCOX database. However, the results may vary slightly by version. The calculation is based on example T17 of the examples included in your software. If you have Thermo-Calc 2023A or newer, you can access the example from the example files icon on your home screen, the Thermo-Calc folder, then double-click on the example file T17. In this video, I will walk you step by step through setting up the calculation. To begin, open Thermo-Calc in the graphical mode and click on the phase diagram template from the home screen of the software. This will load all of the nodes we need for this type of calculation. From the database drop-down menu, select the newest TCOX database that you have available, then select the elements aluminum, magnesium, and oxygen. Next, click on the Components tab. Here, users can define which components to use for the calculation. By default, the selected elements are used as components, but in this example, we want to use the corresponding oxides. Change aluminum to aluminum oxide and magnesium to magnesium oxide. Leave oxygen as it is. Our system is now defined, so select the Equilibrium Calculator node, which is where we will configure our calculation. For this example, we will use mole fractions, so change the composition unit to mole fraction. Under Condition Definitions, change the temperature to 2000 Kelvin and the composition of aluminum oxide to 0.3. Now we want to set the oxygen activity to get 0 missing conditions. To do this, we need to switch to Advanced Mode, so click the Switch to Advanced Mode button. Change composition of magnesium oxide quantity to activity referred to a phase. Select gas phase and oxygen. Set the activity to 0.21, which is the activity of oxygen in air. Under Axis Definitions, change the first quantity to mole fraction of aluminum oxide and the range to a minimum of 0 and a maximum of 1. Set the temperature range to a minimum of 1200 and a maximum of 3200. Leave all the other values the same. Our calculation is now configured, so select the Plot Renderer node. We want to calculate the mole fraction of aluminum oxide as a function of temperature, so make sure the x-axis variable is set to composition of aluminum oxide and the y-axis to temperature. Our calculation is now set, so click Perform at the bottom center of the program. Once the calculation is complete, a plot will appear in the results pane. This plot shows the quasi-binary phase diagram with the composition of aluminum oxide on the x-axis and the temperature on the y-axis. This diagram shows which phases form at different compositions and temperatures. Aluminum oxide magnesium oxide is one of the basic systems in the understanding of metallurgical slags and refractories, and this phase diagram gives a good prediction of which phases form at elevated temperatures. If you liked this example, don't forget to press the like button, and feel free to leave a comment about the type of video you'd like to see next. We are constantly working to create new examples, so make sure to subscribe to our channel so you don't miss out on any new videos. You can watch all of our videos at thermocalc.com in the Video Tutorials section.